In this review notes, we will discuss the fundamentals of AC or alternating current. In Master Electrician's exam, it is assumed that the person taking the exam has strong fundamental knowledge about alternating current. Since most of you knows DC or direct current, there are some information about AC you must add to your stock knowledge. Let us have some comparison about AC and DC to build up the fundamentals we have. I will discuss first the properties of AC and its uniqueness in comparison with DC before we proceed on how alternating current is generated. Okay ba yun sa inyo? Let's proceed. Okay, let us compare AC versus DC so that your understanding will widen. In terms of energy and transfer, AC is safe to transfer over long distances without losing energy, while DC cannot travel very far because it loses energy. This is one reason why Tesla won the war on currents over Edison. With the use of AC, the industrialized world emerged with the use of electricity. In terms of frequency, AC is 50 Hz or 60 Hz depending on the country of use, while DC has no frequency. It should be clear to you the property of direct current. Mostly, these differences are sometimes included in the board exam questions. In terms of direction, AC reverses its direction while flowing in a circuit, while DC flow only one direction in the circuit. In terms of law of electron, in alternating current, the electron flow keeps switching direction, positive, negative, forward and backward, while in DC, the electron flow in one direction, it's forward. In terms of current, the AC current magnitude vary with time, while in direct current, the current magnitude is constant. In terms of source, alternating current came from AC generators and DC came from a battery or cell. Or DC can be coming from a DC generator, but the DC generator use diodes or rectifier. In terms of passive parameters, in AC we called it impedance Z, and in DC we called it resistance R. In terms of power factor, in alternating current, the power factor lies between 0 to 1, while in DC, it is always 1. In terms of wave type, in alternating current, we have what we call sinusoidal wave, or sine wave, or square wave, or triangular, or trapezoidal, while in DC, it is pure line and pulsating. In terms of transformation of voltages, AC can be transformed efficiently in different voltages without losing power, while DC cannot. In terms of storage, AC cannot be stored, while DC can be stored in a battery. This is the great advantage of DC. Currently in our world, mostly the combination of those two currents is used. I hope you gain some insight into this difference of alternating and direct current. Please remember the things that I mentioned. It will be useful when you know the difference. Okay, you have learned the difference between AC and DC. May nadagdag ba na bagong impormasyon sa iyo? I hope there is. Please review it often because some problem on the board exam was formulated around those principles. Let's proceed further in understanding AC fundamentals. AC is produced using AC generator. An AC generator is a device which generates an AC voltage by rotating a loop of conductor material through a magnetic field. To understand the operation of an AC generator, some basic understanding of magnetic theory is necessary, which I know kahit mga bata pa kayo or tayo, alam na natin ang magnetism. I have a topic for that in the coming review notes. For now, let me add a little information about alternating current that is useful for our review. Here's a simple representation of magnetic lines of force of magnet, where north and south poles facing each other. When a conductor of wire was moved between this magnetic field, a voltage will be induced to the wire. And if the wire completes a circuit, a current will flow in that conductor of wire. Then, the left-hand rule will be applied as directed by Michael Faraday, a British physicist who discovered it in 1831. I will not prove to you that there was a magnetic line of force between the two poles of the magnet. This was a basic experiment we had during our childhood years or even elementary science. As I mentioned, when a conductor passes through a magnetic flux line, an induced voltage in the conductor is generated when it cuts the magnetic flux. When the wire is connected in a circuit, you complete a circuit, there will be a current flow. This is the left-hand rule that will establish the basis of alternating current. The thumb points into the direction of motion of the conductor through the magnetic field. The forefinger points into the direction of the lines of magnetic field. And the index finger points into the direction of electron current flow. In the screen shown is a type of a generator where a single loop of wire is rotated in a circular motion in a magnetic field. The direction of the magnetic field flux line is shown in the circular disc. Point A, 0 degrees, point B, 90 degrees, point C, 180 degrees, and point D is 270 degrees back to point A, 360 degrees. The direction of flux was shown also. This simple machine will prove the alternating current if we turn the handle in the direction shown. Let's see what will happen. Let us analyze the movement of the conductor in the flux line as we rotate the conductor from point A, B, C, and D. The arrow in the drawing indicates the direction in which the conductor is moving through the stationary magnetic field. As shown in point A, 0 degrees, and point C, 180 degrees, the conductor is moving parallel to the lines of flux. It cuts no flux line, therefore, no voltage is induced and no current will flow into the wire. However, at point B, 90 degrees, and point D, 270 degrees, the conductor is moving perpendicular to the flux line. Therefore, a maximum voltage is induced and a maximum current flows into the loop of the wire. An important point is that while the wire loop rotates from 0 degrees to 180 degrees, the current flows in one direction, while the wire loop rotates from 180 degrees through 360 degrees, the current flows in the opposite direction. Thus, a term alternating polarity was conceptualized. As shown on the screen, I have X and Y axis. Y axis are assigned for current or voltage, and X axis are assigned for degrees of rotation that represent A, B, C, and D. Notice that the Y axis shows a positive current above the origin, 0 axis, and a negative current below the origin. This is simply to distinguish between opposite direction of current flow. At point A, no flux of line was cut. As we start the rotation of the conductor at 0 degrees, as the conductor moves from point A to point B, current was generated at it reaches peak at point B, shown in the plotted graph the equivalent current value. When the conductor moves from point B to point C, the conductor reduces cutting of flux line and the graph was reflected going to point C. When the conductor moves from point C to point D, the conductor maximizes the cutting of the flux line and the graph was reflected going to point D at 270 degrees of rotation. When the conductor moves from point D to point A, the conductor reduces the cutting of flux line and the graph was reflected going to point A at 360 degrees of rotation. A one cycle of revolution was completed. The waveform that was created is called sine wave or sinusoidal wave. Thus, the current is called alternating current or AC current. If the rotation should continue through another 360 degrees, the current flow would be identical to the previous rotation, One cycle of rotation complete 360 degrees. It is a complete period in a given time. The number of cycles occurring in each second of time is called frequency. One cycle of wave is one complete revolution. One cycle per second is 1 Hz, and 60 Hz is 60 complete cycles in 1 second. Hertz is a unit of frequency in honor of German physicist Heinrich Hertz. We encountered several frequencies operating in our broadcasting station, and you can hear 1 kHz, 1 MHz, 2 GHz. We can use prefixes with Hertz, but in AC electricity in the Philippines, we have 60 Hz. I hope it is clear to you now where we get the alternating current principles. The sinusoidal wave or sine wave, the cycle per second, and the Hertz that may be included in the objective type question of RME board examination, so you better remember that. Here is another formula derived from this cycle. Frequency is the number of times a cycle is completed in a second. Time period T is the time taken to complete one cycle. The unit is second. You may encounter problems like these in the review exam. Here is another problem that you may encounter. The time period of a sine wave is 16.67 milliseconds. What is the frequency of the sinusoidal wave? The choices is 60 Hz, 50 Hz, 58.9 Hz, and 30 Hz. Using the formula, frequency equals to 1 over T, time period, converting the millisecond to second, then performing the operations give us 59.9 Hz, or let's say 60 Hz. Letter A is the correct answer. Here is another question you may encounter. The blank of an AC wave is the time in seconds required to complete exactly one cycle of the wave pattern. The choices are wavelength, period, frequency, or time constant. Well, letter A and B are somewhat very near to the answer. But what separates them is the word second. We know that wavelength is in meter. For letter C, frequency is in cycles per second, so that's not the answer, and time constant is not related. The correct answer is letter B, it's period. Let us end this review for now. Next time we will have part 2 of AC circuits fundamental. I hope you learned something today.
For now, you can subscribe in this channel to keep you updated, or you can visit my Facebook page and like us to support the Master Electricians review. Fractalknowledge.com offered online review app, the mobile app, which will assist you in your review goal. There are tons of questions and answers to build your stock knowledge. The Moodle app is available in iOS for iPhone and Play Store for Android. Please contact the following person and message them for more information. Good luck and see you in your review.